Hello everyone and welcome back to another Universe Sandbox 2 video. So I know it's been a few days since I made a video, so apologies for that, but like I said in the Q&A, I cannot make a video every single day, so yeah, apologies that it has been a little more than usual since the last video. So anyways, today what we're going to be doing is, as you've probably seen by the title, we're going to be bringing back the 1 billion, I was about to say 4 billion for some reason, the 1 billion Luminosity Cypher star. So if you remember this thing, this guy is very, very dangerous. So it's basically a super buffed version of R136A1. So if you didn't know, that star is the most massive and luminous star known here. But this star, this Cypher star, is basically an upgraded version, so it's brighter, and I think it has more mass as well. So what we're going to be doing is, we're going to be putting this in the distance that Alpha Centauri is from the sun, and we're going to see if it affects our solar system from about 4.3 light years away, I think it is. So yes, we're just going to zoom in all the way out here until we find that area. So yeah, about 4.2, 4.3 light years away. So let's try and get that. So 4.2, okay, 4.2, 4.3. So okay, 4 light years. I mean, we've got to pause. Yeah, we're paused. Okay, so 4.3 is Alpha Centauri, so right around there, pretty much. So 4.29, that works. So let's see. This is going to be crazy. If this affects our solar system from this distance, that is crazy. So if we go on the Hattel zone here, we're going to see that this thing, yeah, that's pretty crazy. Even at 4 light years away, the sun is still in the red zone of this star. Or like, it's even closer than the red zone. Look at this. It's in like the black area zone here. So something tells me the solar system is going to be in a bit of trouble. But I've never tried this. I really don't know what's going to happen. So it's over there. You can see it there. And it's still relatively large in the sky. Obviously, it's not as large as the sun. But let's just go to Earth quickly. So, and let's slow down time. So you want to have this on minutes. But it may take, since the star's so far away, it may take a few weeks for it to actually start heating up the Earth and stuff. So, and as you can see as well, even at 4 light years away, it still lights up the Earth. Like, that is crazy. So if we look at the star quickly, so yeah, it does have more mass than R1 does. Radius is the same, but that luminosity of 1 billion, that is a lot. So total energy released every second, 1 billion times more than the sun. That is insane. So if we just go land in the north here, so if we just go ahead and turn all these off like that. So there's Cypher. So it's pretty large. A lot larger than the general star in the night sky. And then there's the sun. So the sun is larger, but for the distance, that is quite big. So this is going to get crazy. Okay, so we're going to hit play. We're going to see if this affects us. Because we are closer than the red zone, so it could just melt the Earth quite quickly. So play. Okay. So let's see what happens here. It may take a while, like I said, but hopefully it will have an effect on the system, or maybe it doesn't. But the whole point of this video is to see what would happen if a 1 billion luminosity star at the distance of Alpha Centauri, would it affect our system anyway? So we're going to go ahead and see. So the closest object to it, I want to say, is Planet 9 here. So how are you doing? Are you going to warm up or anything? So as you can see, it's getting light from this star, but not from the sun. So I don't know what this shadow's doing here, though. That's pretty strange. So okay, let's speed this up. So I'm guessing was it cooling down? Or is it heating up? I want to see this. We may have to speed up a lot quicker, actually. Oh, it is warming up. Look at that. Wow. So yeah, Planet 9 is getting affected, because obviously the sun doesn't affect this planet in any way, because it doesn't get any sunlight from the sun. So everything that's happening to this right now is from Cypher. So that star there. Oh, this is going to be insane. If this causes the objects to get above 400 degrees, that would be crazy. Alright, so let's keep an eye on Earth. How are you doing? Okay, 14 degrees, and we'll turn off climate mode because that does sometimes mess things up. So, okay, it is warming up, I think. Okay, Venus, anything from you? 469, okay, I think, oh, it is, look at Venus. Okay, so Venus looks like it's warming up. So, oh, wow, okay. So we've already done about 62 years of the simulation. But actually, maybe not, or maybe a little less, since this simulation, because it's my custom system, it does start a few years ahead. So yeah, this could be a little bit, but as you can see, that's warming up. How about Mars? Minus 66, that's a little colder than usual, I think. Jupiter, minus 153. Okay, so let's speed up a bit more. So let's go to yeah, let's do this. Earth. 15 degrees. So Earth isn't really changing much, but Venus, since it's got that higher greenhouse effect, may be affected, but it looks like it keeps on going up and down there. So I think that's just where it is in its orbit is causing that. So, okay. Mercury, same with you. So it looks all like the outer system. These guys are a little closer. Sedna, maybe? You warmed up? Are you getting sunlight? You must be. Let's see here. Yes, yeah, so Sedna. Oh, is it? Oh, yeah, it is. You can see just there. Very, very dim here, though. Yeah, very, very dim, but it is receiving light. Pretty weird. How was this one really dim, but the planets closer to the sun are getting light? That's pretty strange. Yeah, Uranus is getting light from that star. That's pretty crazy. We will try this in the normal solar system simulation as well, just see if it makes any difference, but it should be fine the way it is. So, Planet 9, we're going to keep an eye on you, because that seems to be the main candidate for being affected by the star right now. So, let's see if anything happens. So, yeah, these guys are all going very quickly, so let's see here. Anything at all? Doesn't look like it. Even though it's 1 billion luminosity, doesn't seem like it will reach the system, or doesn't seem like it will affect the system in any way so far. So, maybe if Alpha Centauri was the star, we'd be fine. But I'm guessing a lot of radiation it probably releases into space probably wouldn't be too good, but probably would take time to reach us. Maybe it would dissipate a bit, but I don't really know about that. So, let's see here. Come on, game, you're going to do anything? Come on, we want to see some action. What if we play around with the settings a bit? What if we turn this off? Lower this option a bit. Is that going to do anything? Please? Whoa! What the hell? Okay, I don't know what happened there. That's pretty crazy. I don't know what happened there, but I guess this simulation's a bit screwed. I don't know why. Yeah, this option is very buggy, and it doesn't, because as you speed up time, it makes the game do less realistic things, so it just throws out stuff for no reason. So that is quite annoying, but we have to deal with it. So Planet 9 has moved a bit, but yes, it did cool down a little bit. So if we just go into a new simulation here, so let's go to the normal Planet 9 in our solar system. So let's go to the Planet 9. Where is it? There we go. Okay, so we're gonna have to deal with the generic Planet 9 look, and I'm not really a fan, but we'll just have to roll with it. So now let's try that again. So let's go pause. Let's see if we get any different results in the normal solar system. So 4.3 light years again. So let's go all the way over here. So 4.3. Is that 4.3 there? 4.2, 4.1. So 4.3 is there. Okay. So there we go. So Planet 9 as well is there. So it's still relatively close. Whoa. What is going on here then? Looks like these guys are in a binary orbit. I don't know what's happening here. So, play. So there's the star. It's making really weird orbits. But is it going to affect anything? That's what I want to know. Anything going to happen? Earth? Anything with you? No, doesn't look like it. Venus? Anything here? Nope. Same results, looks like. I know the star's obviously in a different spot to where it was last time, because Planet 9 is a little further away, it looks like. But Planet 9 is cooled down a bit. Anything with these objects? No. Okay, so looks like to conclude, we're not going to get any action today, but one of you guys did ask me to, so I think it was actually Cypher who asked me this, who actually asked me to make this star in the first place. I mean, I think you told me to do this, so it looks like even if, well, it looks like the system, sorry, is safe from Cypher, even though it's in the red zone here. I don't really find these discs to be that accurate, because if this was like the red zone of UI Scutty, I think it probably would roast it. But just because this is obviously a custom object, it is obviously going to give us different results. Because custom objects will always be, especially custom stars, they've always been a little more faulty than normal stars from the menu here. So in the normal star menu. So yeah, but that's the closest we can get to the stars, because yeah, the custom objects or custom simulations as well, they do things slightly different than main simulations sometimes. But yeah, there's the normal yes, this is more of a trustworthy disc than this disc, the really big disc, the Cypher disc, or the Hatwell zone, whatever you want to call it, because yeah, this doesn't, I don't really see, like, if it was in the red zone, you'd think it would roast everything, but apparently not. So I think what we're going to do today, just so we can get some action, hopefully this will work, is what we're going to do is we're going to put Cypher at 1 light year and see if it does anything from there, just to see. So we do want to get some action. We don't want to have a boring video where nothing gets destroyed, right? Like, we've got to destroy something. So, okay, 1 light year. So place you there. Is it going to do anything now? Let's have a look. So, okay, anything? Maybe not. Oh, even from 1 light year, it maybe doesn't do anything. Oh, no, Earth looks like it's warmed up a bit, actually. 30 degrees? I don't think that's a normal Earth. Let's check on Venus. So it is receiving sunlight as well, as you can see. So where's Venus? 500. See, it wasn't hitting 500 earlier, if you noticed. So the star has had a little effect on our system, it looks like. So it's 496. So as it gets closer to the star, as you can see, so the star is there. It seems like it does fluctuate a little more. Like, maybe it's a simulation. I'm willing to say that that star has caused some sort of change. So now what we're going to do is, that is a big orbital period. Look at that. So let's delete that. Now let's add it at 0.75 light years. So let's see here. So okay, 1 light year. So oh, it's only in AU now. I don't know what 0.75 light years in AU is. Let me quickly try and translate that. So let's do AU to light years. Okay, so here we go. So we want 0.75. So that is 47,430 AU. So let's try and do that. So let's cipher. Okay, so 47,000. So this is about 0.75 light years here. So let's see if any change happens now. So is Venus going to warm up more? Because I think Venus is the best thing to look at here because it has the best greenhouse effect. So anything... Oh, and it does. So, yeah. So even... Because when we first did it, it definitely warmed Venus up above 500 degrees. Because Venus, with the sun, Venus doesn't go above 500 normally. So now this star is at 0.75 instead of 1 astronomical unit. Or not astronomical unit, light year, sorry. Venus has been affected slightly, and then I'm guessing, yeah, since Venus has, Earth as well, 57 degrees. See, it wasn't like that before. So, at the distance of Alpha Centauri, it won't do anything. It seems it will not affect the system, apart from maybe Planet 9, as we did see. It did seem to cool or warm up a bit, but it looks like at 0.75, it does start to have an effect. So now let's do 0.5. So let me just quickly translate that again. So 0.5 light years. So that's 31,000 AU. So let's go back here. So let's delete you. So then we'll go and get another one. So let's do 31,000. And also, guys, what I'm thinking about as well, expect another custom objects episode coming out very soon as well. So yeah, stay tuned for that. And also as well, we hit 2,200 subscribers the other day. So many thanks to everyone who's new. Hopefully you enjoy the videos, and yeah. So, yeah, I hope you enjoy and welcome as well. Anyways, so 31,000. Okay, so 31,000 is there. Yeah, I can't believe we got to 2,200. It's not even February yet. We're doing pretty well. But I really want to try and get 3,000 soon. That would be awesome. Just try and get it before the summer, maybe. That'd be cool. Or before June and July, somewhere around there. So, okay, so 31,000. So that's about 0.5 light years around there. So now let's see. So it's even closer again. It's another 25% closer. Venus, let's check you out, buddy. So, look, it's starting to glow in temperature now, look. And its clouds are starting to get a little thinner. As you can see, we can start to see the surface of Venus. So, that's okay. So it's getting hot there. Look, 500. Is it going to get to 560? Doesn't look like it. So it's just below 560 degrees. Is it going to make it? No, 559 is the highest Venus will go. How about you, Earth? 95. The water's going to start evaporating soon. Once it gets to 100, that water could start to evaporate a bit, so that's not good. So poor old Earth here. It's gonna get roasted. Look, as you can see, some of the land or some of the water has already disappeared. So let's see here. So if we just do this quickly, so get rid of all that. So there you go. So it looks like yeah, the United Kingdom is now all part of Europe, so it's all connected by land now since there's no ocean anymore. Looks like the Mediterranean Sea is all locked off from the Atlantic. Look, so as you can see, Portugal is now touching the north of Africa there. So this is the Mediterranean Sea, I think it is. So Italy is also connected to Africa with all this drier land here. So that's pretty cool. Also got that part there. So it looks like Saudi Arabia is also connected to Africa there now. Okay, that's pretty interesting. Yeah, you see India's also gained a bit more land. Is this Indonesia? I can never remember this bit. I think that's Indonesia there. Somewhere here. Or let me see, Australia and New Guinea. I can never pronounce that one. I'm sorry if that annoys anyone. Remember, I'm not a good pronouncer. So yeah, that's all connected together. We can see up here. Where is it? Look, yeah, you can see all of this part here. China, Korea, this has all gained extra bit of land with all this bit. Japan is now connected to the rest of Asia, as you can see. Let's check the Americas. Where are they at? Anything with Antarctica? Yeah, all the ice is pretty much gone now. Snow and ice. A new continent there. Is this a new continent? Or a new piece of land? I don't think that land's normally there. Or am I just... No, I'm pretty sure that isn't usually there. So there's Africa. Okay, America. So we'll go on flashlight mode just to see what's up here. So, okay. So, yeah, looks like the bottom of Argentina. And yeah, that's Argentina on the left of South America there. Yeah, this area's gained some extra land as well. This island here... Whoa. Whoa, 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 whoa. Yeah, so that island is now connected to the rest of South America now. So there's that. Okay, cool. Yeah, there's hardly any ice left on there. Let's see here. Florida has almost closed up the Gulf of Mexico. So the Gulf of Mexico is almost solid land now, completely. So it looks like it's connecting to the part of the Caribbean islands as well. They're all starting to become one big area. The Central America here, so just south of Mexico, this is started to get a bit more land as well. What? Sun? Seriously? Come on now. Alright, let's go back. So, yeah, where's the rest of America? So, how's Canada doing? So Canada is all of these islands of Canada, they've all connected to mainland Canada, and that's all connected to Greenland. And Greenland is almost connected to Iceland, which is obviously connected almost to the north of Scotland and the UK here. So yeah, the world is starting to dry up, and a lot of I can never remember the north of Russia. Is it called Siberia, the north of Russia? Because this part's usually uninhabitable, I believe. I don't think any humans live at the north of Russia because it's very cold up there. So, yeah, I think that's called Siberia. That's all started to close up. The North Pole has completely gone. It's just liquid ocean now. So, yeah, poor Earth is really getting warmed up here. So, let's keep going. Anything going to happen? Any more water? Oh, it's hit 100, look. Just hit 100 degrees. Okay, that's not good. Okay, so let's go away from Earth for a bit. Mars. Oh, Mars is in the positive temperatures now, so we could colonize Mars, but hopefully it doesn't get too hot. Gas giants, still in the minuses, it looks like. Planet 9, where are you at? -9 degrees. Whoa, okay. Yeah, so Planet 9 is the closest, as you can see. So being that little bit closer, well, actually, it's actually a big distance. Being that big distance closer than the rest of the solar system here, has almost made Planet 9 into the positive temperatures as a gas giant. What is this shadow here? That's a very weird... What is it? Why does it do that? That's pretty strange. Like, it goes as I move my camera around. That's pretty strange. Yeah, if anyone knows why it's doing that, let me know. But yeah, Planet 9's almost in the positive temperatures now. And we've only been going for 30 years, as you can see. So that's the time since the simulation started. So we're in the year 2047. And I think we started in the year 2013, around there maybe. So yeah, a lot of action happening since we've moved the star closer. Anyways, it's at 0.5. Let's move it to 0.25. So what is that in AU? So in AU, that is 15,000. Around 15,000. So let's go back here. So let's delete you. Yeah, we've got it paused. So delete you. So we want 15,000 AU. So, oh, look how close it's getting. So 15,000 is there. Oh, it's getting a lot closer. Oh, it's getting bigger as well. Okay, so Venus. I'm going to check up on you first. 700 degrees straight away as soon as we hit play. Earth. Oh, Earth. Oh, no. All the cities' lights have just disappeared if you saw that. So let's see what's going on here now. Oh, poor Earth. It's getting really roasted now. So all of the land has gone brown. There's not really much. The green is starting to disappear. Oh, God. Poor Earth. Really getting roasted up now. So, oh, still surviving the temperature. Oh, no, that's getting really hot now. Oh, God. Look at all the extra land being made. This isn't good. Look at this. The Atlantic Ocean's drying up. The area where the Titanic is probably almost, or is probably shallow water at this point. All of them, the north of the planet is all connected now. Like, we've got the United Kingdom, Iceland, Greenland, Canada, Russia is all connected together. So the whole world pretty much is connected now. So, yeah, there's like even Antarctica is connected to all of these paths and stuff which link up to the top of the world there. So, damn, Earth is finished now. Yeah, 144. Yeah, good luck living there. Yeah, and all the water's completely gone, so it's all just one big continent now. Well, rest in peace, Earth. Well, look how hot it's getting now. That putting it from half a light year to 0.25 light years, so a quarter of a light year. That's really made a big difference. So pretty crazy stuff. All right, gas giants. I'm guessing these guys are in the positive. Yeah, Neptune 90 degrees, Uranus 89. Wow. How's Planet 9? you are at 98. So yeah, these guys are really warming up now. Alright, now, let's put it, so it says 0.25, let's put it at 0.1 light years. So 0.1 light years is 6,300 AU. So let's delete you. Okay, so 6,300 AU. So around here. Okay, look how close it's getting to planet 9. Okay. And after this, we're going to put it less than a light year. We're just going to... Actually, we'll just put it where planet 9 is. I think that works. So, play. Okay, yeah, we're going to start seeing stuff get really hot now. Venus is glowing. You can see it from here. 1,100 degrees. Earth is at... How are you doing? 387. Mars is probably too hot. Yeah, 318. Yeah, so the solar system's compromised now. Nothing... Life probably won't be able to survive here. Yeah, Eris, 362 degrees. Pluto, 258. Yeah, so the system's gone now. As you can see, Planet 9, 354. So now what we're going to do is... Planet 9 is 2,600 away, but this thing is about... Well, how much was Cypher? Cypher was 6,000, so that's 3 times further away than Planet 9 is right now. So we're going to go and manually do this. We're going to drag it to where Planet 9 is. And as you can see, this star has basically moved from 4.3 light years, where Alpha Centauri was. We've brought it closer and closer and closer. And now it's roasting everything. So yeah, every object in the system here is all burning up, as you can see. So yeah, rest in peace system. So yeah, there you go. And Planet 9, closest by miles. Probably not going to last too long. But look at Cypher here. Look at this guy. Look at this thing. In fact, should we just end this? Let's just end this. So, oh god. So yeah, as you can see, they are really, really close to the star now. So let's go ahead and delete all that. We'll leave trails on though. So we're going to just drag it a little closer to Planet 9 here. And Planet 9 is probably not going to survive this. So let's just drag it closer and closer and closer. And Planet 9 is just going to completely vaporize, as you can see momentarily. Yeah, and Planet 9's gone. So let's do this. And now let's bring it a little closer. So let's put it there. So let's zoom in on you as well. So let's bring it a little closer. So come on, move. Please. Come on, you're going to cooperate. Come on. There you go. So let's see here. Oh gosh. Orcus, how are you doing? Yeah, look, you're really losing mass now. All this stuff. God. Alright. Cypher. Let's put you there. Watch these objects all just disappear. Look, ready? They're gone. And boom. There you go. It's eating everything. Uranus, you're next on the kill list. Closest object now. So that's pretty crazy. Okay, here we go. Closer and closer. Uranus. Sorry, buddy. You're not going to make it. And it's gone. Okay. And, oh, Uranus. Oh, it's still going. And he's gone. Alright. Now what we're going to do is... We're gonna pull it really close. So a lot closer. It's only 6 AU away from where the sun was now. So come on, drag already. What are you doing? Come on. Wow, this really doesn't want to work with me, does it? There you go. All right. Oh god, the sun's incoming, and we're gonna get a nova, but it's too late. It's pretty much killed everything anyway. And kaboom. And that's pretty much everything gone, apart from Jupiter maybe. Oh, now we've got a black hole though. That could consume everything. So, kaboom. So that's a big nova there. Look at it. 251 masses of sun in that nova. So, yeah, Jupiter and Saturn are probably the only things that may survive. Or Neptune as well. So, let's just see here. And actually, what would happen now? Since it is a black hole, it's going to be total velocities. Everything's going to go piling on that black hole. So, yeah, that pretty much is it. This isn't relevant to the topic of this video anymore. So, yeah. You can work out what happens from here. Every object's pretty much going to get destroyed. So, hopefully you guys all enjoyed this video. Make sure you did hit that like button, subscribe for more. Stay tuned for the next custom objects video that'll be coming out tomorrow or in the next few days. So yeah, there we go. So what do you guys think of that? So to conclude from this though, if Cypher, the 1 billion luminosity star, was the distance of Alpha Centauri, it wouldn't affect the system really. Apart from Planet 9, the system was fine. It's only when we started to move it to about 1 light year where it started to, you could see Venus and Earth warmed up a bit. So Venus warmed to about 600 degrees and Earth I think went into the 20s or 30s or 40s around there. So you could see it was making a difference. As we made it closer and closer and closer, obviously the 1 billion luminosity pretty much just roasted everything. So that is that pretty much. So yeah, end of solar system. So yeah, hopefully you guys enjoyed. Like I said, if you want me to do it with 1 trillion luminosity, then we can try that. Just let me know down below. And yeah, there we go. So that pretty much does it for the video, guys. So yeah, make sure you guys all have a great day. Subscribe if you're new, and I'll see you in the next video. Goodbye.